Awesome. Hello, thank you for having me. This is units as a tool of communication. Units. Well, when we talk about quantities, oh, wait a second. When we talk about quantities, we usually don't use bare numbers. We usually say 12 meters, 3 feet, 1 cup, 5 minutes. The unit tells you what the number measures and ties it to a shared standard, SI, or something that's convertible to SI. What makes units the closest thing we have to a type system that is in everyday use. It's the vocabulary people use to keep quantities meaningful. So if we want a programming language grounded in how people normally communicate, like I do, units are a good fit. The same grounding that lets a person read a unit and know what it means also lets a runtime act on it. The easy case is in a direct dimension conflict. A system can refuse to add a length to a mass. The more interesting case is what comes after dimensions cancel. An aspect ratio and a gear ratio may both mean dimensionless, but they certainly don't mean the same thing. A simple dimension check treats them as identical, so the addition would pass. Provenance is the mathematical history of how the value was built. And a semantic check can catch a whole class of mistakes that dimensional analysis alone would miss. So what would a language with grounded units built in look like? Here's one. Dictatable is designed to be read out loud. It is a computational pigeon that reads like a natural language. A full stop ends a statement, is defines an immutable relationship, let be binds a mutable tensor. Render displays a result. Identifiers are noun phrases, operators are verb phrases, including many array programmers always say out loud. Iota, reverse, tally, sum, commutative sum. A line reads like a sentence. Render characteristic length divided by time step. With APL, Ken Iverson showed that notation is a tool of thought. Dictatable spells that notation in words instead of glyphs. The sentence you say to explain the program is the sentence the system runs. As you've already seen, you write the units right into the sentence. Whether it's a flow velocity or a density, each tensor carries its unit as a tag, anchored in SI. When the runtime composes these tags, density times flow velocity comes back as pascals. A unit is generated, not one you typed. And it rides with the tensor as a sidecar through the computational graph. That brings us back to the hard case, and to that provenance check. Reynolds number and Courant number are both dimensionless, so dimensional analysis alone would not let you add them. Dictatable rejects the sum because they are distinct named quantities with different derivation histories. And that check runs on every keystroke, flagging the mistake you type. If you catch that collision after a run, it's a postmortem. If you catch it on the keystroke, it is a tool of thought. And said out loud, a tool of communication. Thank you. And if you want to see what an actual array program versus a scalar-like one is, here's Conway's Game of Life. Thank you.